Hey y'all, CB here at MBS Welding in the tool room here doing some thinking, and I got a buddy that wants me to build him a snow pusher. And basically we're just going to be building a snow pusher frame, and he's going to be bolting a used set of excavator tracks to this frame that we're going to build to use it to push snow this winter. And this is going to be cool, so I'll show you a couple images of one that he found. I don't know where he got these images, and I don't know who's got this machine or if he just found these pictures online, but this is an idea of the snow pusher he wants. The shape is a little bit different than what he wants, but this gives you an idea of what we're building here. So the tracks that my buddy's got, he took them off, cut them in half. They're rubber tracks. They're make a total 17 foot 8 inches. And he wants to make this thing as big as he can make it. And the shape that we're talking about doing would involve, you'd have a 10-foot section that's straight. Then you'd have a section that goes 45 degrees to make a 90 on each end. So that's the shape of the snow pusher right there. And then we'd have a regular, like a Bobcat quick attach, loader attach right here. So you could use this with a skid steer or tractor or anything that's got that quick attach that will lift this apparatus. So if he's got 17 foot 8 and this is 10 foot, and we figure the end of this, I'm imagining would be a foot. So that gives us 12 foot that we're going to be consuming. If that's 10 foot right there, the simple thing would be to say 10 foot, 11 foot, 12 foot, and then each of these would be 2.5 feet. So that makes 5 feet, 15, 16, 17 feet. And we'll leave the 8 inches just be. That, you know, it could stick out the end, or it might even get cut short. Who knows? The other thing about it, as far as the bars, is he was thinking from the top of the top bar to the bottom of the bottom of bar is going to be 33 inches. And that's not a critical dead-on sort of thing either, but that's what we're going to go by. So I'm imagining for a couple vertical pieces, we would line up a couple vertical pieces depending on the size of the quick attach adapter. And, you know, then maybe do another vertical somewhere in here. I don't think we need one on the end, but we might put one on the end just because it would give him something to bolt to. Or we could cap the end off with a pipe. I don't know if that would make any difference as far as pushing snow or not, but different things we can do here. Now let me show you about some other material. He's basically, he's going to be using a used set of the rubber excavator tracks to bolt into this thing. And let's show you what other material he's got we're going to use. We're using what we got here. So here's some material that he got for free. This is a 3-inch pipe, and looking at the thickness of the end of it, I'd say it's a Schedule 80. So we got a 3-inch Schedule 80 gas line pipe. You can see this green epoxy coating. This is called Fusion Bond. That's going to make, there's a couple things here about using this free material that's going to make the fabrication a little bit more complicated. One thing is you can't weld this Fusion Bond, where you got to work on it at where there's Fusion Bond. You got to grind that off or burn it off, power brush it, get rid of it. So the Fusion Bond epoxy coating is one thing that we got to deal with. Another thing that's different than the thing in the picture is, since this is pipe, you're going to have something with fish mouth copes that we got to fit up, rather than just like square tubing that you could just cut. You know, if we cut square tubing at 22.5 degrees with a saw and put two of them together, you'd have a 45 boom bang. We're still going to be using the saw, and we're still going to be cutting the 22.5, but where we have uprights, well, let me get back to that. On the pipe miters, the rotation is something that you kind of got to deal with. And when you're cutting, when you're putting miters together with square tubing, it kind of lines itself up. But the other thing is, where we're going to have vertical pieces, we're going to have to be making fish mouth cuts where, you know, the pipe fits into the other pipe. But we're saving so much money on the material that we're going to put a little bit extra work in the labor. I've fit a lot of pipe. I've cut a lot of fish mouths, so it's not going to take me that much longer, but it is a little bit more work working with pipe than it is working with tubing, and it's a little bit more work working with fusion bond gas line pipe than it is clean pipe. But let's get to it and get this thing built for him. Couple of key items here for this job. We got the 2-ton hoist that's lined up over top of the roller rig for the saws, and the hoist is critical because you can't lift this pipe. Schedule 83-inch, man can't lift that by hand. The next thing that's critical on this is the rollers. This pipe's so heavy, if you put a mark on it and you want to slide it back and forth and line it up with a blade, without those rollers and roller bearings, it would be really hard to get your pieces lined up where you need them to make that blade hit the mark you made on the tubing. Without the rollers, that would be really rough. It's just heavy. And then the next thing is, with the dual saws, I can have that one saw set at 22.5 degrees and the other saw set at 90, and I'm not going to have to keep changing my miter. Now, what I want to show you here, this is a little test piece I did, and with my saw at 22.5 degrees, I took a half slice off a pipe, and then I rotated that little piece of pipe 180 degrees and took another half slice off. And you see what I've made here is a cope that fits the pipe into the other pipe. Nice fish mouth. Next thing we're going to need to know is from like the center of the pipe to the end of the pipe that I got to cut, we get an inch, and that inch needs to be dealt with. So basically we're trying to figure out how long to cut these pipes so that we'll have enough steel added for our cope, which on each one, you know, we know from center down is going to be an inch, which is 2 inches. And so from the outside, which is 33 inches, to the center of the pipe is going to be the diameter of the pipe. So we're going to use our project calc, which allows us to do fractions, and we're going to say 33 inches minus 3.5 inches equals 29.5 inches, and that takes us to the center to center on the pipe, and then we want to subtract 2 inches from that, and we get 27.5. What I'm trying to show you here is we're figuring this out so that we know that if we cut our pipes 27.5 inches and then we do the cope on the pipe, then we're going to come out with 33 inches from the top of the top to the bottom of the bottom of our rails. If you'd like to buy an NBS Welding t-shirt for $25, send Boss Lady Tina an email request, nbswelding@aol.com. Here's a close-up look at that sample pipe that I did, and you can see here, taking a half a slice off, rotating the pipe 180 degrees, put it back in there, and on this I'm doing a 22.5 degree angle, and it worked out. Sometimes it works out on some pipes to be 30 degrees, but this is kind of what you want as an end result. You want, you know, fish mouth cope where they fit together, and you can adjust the angle to see how it works out for you. Now, on the other pipes I cut, I was left with this one piece that looks like it's maybe 5 feet long or something, and I'm getting ready to make my vertical sections, and there's a bunch of those that are the same. So what I'm doing here is I've set up a stop. I measured that one, and now you can see that I'm not measuring anymore. I'm just using the roller rig to roll my pipe up against my stop and making the cut. So we've got a bunch of these that are the same length. Obviously all our verticals are the same. And I'll use a center head and then a piece of angle iron, and you can see me using the angle iron to get a couple of lines that are straight across from each other. Center of pipe to center of pipe. Then I take my half a cope, rotate 180 degrees, take a half a cope, turn the pipe around, and do the other side. And this gives us the piece that we're looking for our vertical sections with a fish mouth cope, top and bottom. All our parts made. Let's get going on assembling this thing. Now, the part I decided to go ahead and put together at first is this H section. And it's going to be where the Bobcat Quick Attach goes on to this snow pusher. And this is a part that I'm really going to probably weld really good. Not all of this thing needs the, the highest quality welding in the world. And my buddy's not going to want to pay me to play with it. If I can make it hold, he's going to be good with it. And on this section, though, that I can flip around, it's not going to take a lot of extra time to make a really good weld, and it needs to be really strong. So I'm going to show you what can be done here with the Arc Captain and the 030 solid MIG wire and a mixed gas. I've run 2 passes downhill, 1 uphill, and this is what you come up with. I would consider this to be welded pretty good for a pipe T on a fabrication job. And then I'm going to show you an example of the way that I'm welding the miters together on this job. I'm not taking the time to bevel that pipe. And since I'm not beveling it, the gap in it is critical. And that's what I'm trying to show you here, where I've got about a 5/16 inch gap, very even all the way around. And that's so I can get a bead as a backer bead really deep back in there. And then my final pass will fill that up really well and make a fairly strong weld for the amount of time that I put in it, considering that I'm not taking the time to bevel it and whatnot. Another trick that we're going to do here, we're going to use the 45 bubble on the torpedo level to assemble this. And you can see what I did there. I laid my parts flat on the table. I got 2 tacks that I can hinge that part on. And then I used the 45 bubble on the torpedo level to make my 45 degree even with the other. Now, a lot of people will say, oh, you got to get that level, that bottom section level. I don't necessarily do that. If I throw that thing up on the table and I can throw my torpedo level on it and it's level enough to say that, hey, this bubble is touching the line to the right, then I'll just do my 45 piece with the bubble touching the line to the right. It needs to be the same. It doesn't necessarily need to be level. If you're assembling stuff like this and you got one section that you're throwing your level on, and it's touching the bubble to the right, and then you put it on a section that's supposed to be plumb, and it's touching the bubble to the right. For what we're building here, that's good enough. If you're putting any more time into it than that, you're wasting time. And on something where we're doing 90s and 45s, if this saves us drawing the whole thing out on the table and making a layout, then it's saving us a lot of time. You can see right here, I've got that longer 10-foot section, got it level or level enough, and then the other section, I just get it plumb or at least matching whatever the level section is, and that's putting me together real quick. And here you can see I use the torpedo level to make sure that these 2 ends match one another. I don't want one pointing up and the other one pointing down. But there again, the torpedo level assembly is a fast and efficient way to put things together when you're talking about 90 and 45 degree sections. And then here we go again. We're going to use the torpedo level. I've got this thing set up on the table and it's level, and now I'm going to put my H section on with it plumb. I've only got to worry about it in one plane. The other way, it's going to square itself. We already set the other way when we built the thing. And I'm just showing you here the way I'm going about assembling it. And these vertical sections here, the trick with those is tacking them in the right place, because you want to be able to hinge on your tack. I'll set a section up there. I'll put my torpedo level on it. And if it's leaning to the right, I'll tack it on the left. That means that I can lean it on that tack to where it needs to be to get it plumb, and tack it again, and I'm good. You know, if it's leaning to the right, and you tack it in the wrong place, you know, and you tack it on the right, then you're going to try and lean it left to get it plumb. You can't, it won't let you. That's why you got to put your tacks in the place where you can use your tack like a hinge. If it's leaning to the right, you tack it on the left. Then you can lean it from the right to the left to get it plumb, and tack it again, and you're good. Now, another couple parts we're going to be putting together here. The end section of this snow pusher on each end is just going to be a square cut pipe with caps welded on it. Now, I could have put these in the welding positioner and rotated them, but for what it is, it's probably just as easy to lay it up on the table and rotate it by hand and get it welded. So what we're doing here, I've got my pipe cut to length. I've got some caps that are, they're discs, basically, 3.5 inch circle of plate. And I'm welding that cap on the end. And then to move on with the assembly, can actually use the snow pusher frame to assemble itself as far as putting this top section on. I did have to use a mini puller and squeeze some stuff together to get it where I needed to be. And overall, just, you know, I'm laying the parts into the copes and putting them together. And then I've put it up on the table here in the right position where I can just lay these in place, these end sections. I've got the fusion bond epoxy coating grinded off where I need it, grinded, sanded off there. And, you know, I can just, with them setting in this position, I can just grab that part and lay it there in those copes and weld it up. And so, and also as I'm assembling stuff, you know, I'll get welding done where it's easy to weld it. There's going to be times during your assembly where some parts that need welded might be, like if it's upside down, you might not fool with welding it then, you know, especially if it's something you're going to turn, where later on in the assembly it's going to be easier to reach, then, you know, you're going to weld it then. You don't want to do the welding on the worst position possible. Not that they all need to be absolutely ideal with regards to positioning, but, you know, as I roll it around, I'll take advantage of the positioning. Now, I do got one really bad fit here, and I'm going to show you how I'm going to deal with that. Now, you don't want to shove this thing tight together just because you've got a big gap on one side. That would cost you penetration that we need for strength. I've got my 5/16 gap that I wanted on the tight part, but now I've got a 1/2 inch gap on the other side, which is a little too wide for me to weld. So I want to show you how I'm going to deal with this in this situation. I could have refit the whole thing, but that's not the most efficient thing time-wise to do. I'm taking a 3/16 inch welding rod that I've busted the flux off of, and I'm sticking it in here, I'm tacking it, and I'm rolling it around. And to achieve the strength that we need and take advantage of this rod as a backer, the important thing is that the rod is put in there deep. I don't want it flushed out. I want it way back in there because I still want to get my strength out of my weld by putting my weld between these pipes. And if I put the rod directly between that fit, that's not going to be strong. You want the rod way deep in there as a backer, not as just a filler, but as a backer. And then, you know, between your rod and your pipe, your miter, you put you a bunch of tacks, and then once you got all your tacks in there, you make these welds. But look at these welds. You know, they look like a beveled pipe. I still got plenty of room to get a strength weld in there. And that's the key thing that I want to show you about cheating that fit is, you know, do it. Cheat that rod in there, but cheat it in there deep so it's a backer and not just filling it up with crap. So this is a jig that I made a couple years ago, I think. I don't know how old it actually is, but it's a jig I made for a Bobcat Quick Attach, and I've got it set up there where, you know, I can use it to position my parts and get them on the right angle to build a Bobcat Quick Attach plate onto the back of this implement. Starts out with 1.5 inch by 1/4 flat bar. Then I'm going on there with a 1/4 by 3 flat bar. And I'm going to leave the bottom alone. And I'm just, at this point, going to spin this thing around in place and get my tractor and fit it up with the tractor and lift it. Now, I will tell you, my tractor is too small, really, to run this as a snow pusher. I don't think my tractor would have the kind of pushing power that you'd want for this big of a snow pusher, but it's still, you know, it's good to use it as an assembly. As an assembly machine, it's fine. And I had to notch it. I had to notch my bottom plate a little bit. So I used Arc Captain Plasma to notch that out. And now I'm getting that in position. And then right here, I've got my Arc Captain MIG 205 MP Impulse MIG. And I'm going to weld some of this up in Pulse MIG. And the thing that I wish I had done was turn the radio off when I did it. Because I would like for you to hear the audio on this. But since I was playing the stereo in the shop, the music will stop me from being able to put this on YouTube. So in the next part, I'm not going to pulse. I'm going with maximum voltage on the Arc Captain MIG 205 MP. So the maximum in this MIG mode is 26 volts. And we're going to do a little duty cycle testing on the Arc Captain 205 MP. And let's check that out. I'm going to make some long welds with it at 26 volts with 030 wire, 640 inches a minute wire speed, and I think I ended up moving that down to 620. So let's check that out.